Okay, this one, okay. So use the black one. So we define this calculation now like this, okay? So the Q is still, as previously I said, this is already in the y functions, okay? So this is the boundary for x. But what about y? Y should be constant, okay? From 0 to 2. This is y. And then y, it should be from 0 to 2. Okay? So we use this area. So this one is actually our r. Okay? Okay. So we answer these questions. Okay. So I rewrite again the. Remember, I would like to do it first in the x directions and then y directions. Okay. The boundary for the x directions is actually from y squared to 2y, and then for the y direction itself from 0 to. Okay. First of all, we would like to solve uh, this one. Okay, this area. Okay, 2xy. If we integrate with respect to x, what do we have? X squared over 2, and then this is vanished. And then, sorry, this is y, and then the x itself is from y squared until 2y. Then this is still the integration in the y. So I substitute again. I will rewrite again, not 0 to 2. So I will replace the x with y squared. Y squared square times y. Sorry. So the order is wrong again. Okay, now this one, okay, 2y. 2y square times y. The minus, and then I replace it, the x with y square. Okay, this is y square times the y. So this one is actually dy. Okay, and then I will break down this one. This it become 4. Yeah, that's correct. Y to the power of 3 minus, this is 4, 5. Okay, y to the power of 5. And then we integrate, the rest is dy. Okay, the dy we integrate, it's okay, let me do it here. So y to the power of 4 divided by 4 times the 4 constants. Okay, then y to the power of 6 divided by 6, and then y itself is from 0 to 2. Okay, so what do we have? I erase this. So we have 2 to the power of 4, which is 32, I guess. Okay, 2 to the power of 4 minus 2 to the power of 6 divided by 6. Okay, so what do we have? Let me first check. Okay, so this one is actually 64 minus 2 to the power of 6 is, okay, I will break it down first. 2 times 2 to the power of 5. This is correct, right? And then 6, I divide it by, I break down as 2 times 3. So I will delete it. Okay, and then this one is 64 minus 2 to the power of 5. Okay, 2 to the power of 5, which is 32 divided by 3. Okay, so this one is actually the answer. You can write down this. Okay, so this is the answer of the questions number 2B, 2C. Okay. Okay, now we go on with number 3. Okay, Number three, let me go to the questions. Okay, this one is number three. Number three is calculate the integral, this one, okay? So we just solve it somehow. To y, this is integral of e to the power of minus x squared dx dy, okay? And then from 0 to 2, 2y to 4, okay? Can we solve this directly? We try, okay? We try directly solve it. This one. Solve this one. So from 0 to 2, and then, what is actually the integral of this one? Okay, I will try to investigate first, okay? What is actually integration of this one, dx, okay? How can we calculate this? Using substitutions? Substitutions? We don't know. We try, okay? So if we can try, okay? So for example, u is minus x squared. Du is minus 2x dx, okay? And then dx is minus over 2x du. Can we use this to solve this? Can we? Let's see. Okay, we try, okay? Nevertheless, we try. E to the power of u, and then dx with respect to, we replace it with minus 2x du. Oops. What do we have? We have this one. Cannot be cancelled with anything in here, okay? So, substitutions, fail, okay? Okay, how do we do? So, since this one is actually double integral, we can actually move the order of the integrations. The order of the integrations, okay? If we can calculate which one is easier, calculating e to the power of x with respect to x, or calculating e to the power of minus x with dy. This is easy, okay? Very easy. What is it? Okay, this is simply y e to the power of minus x squared. Okay, because this one is considered as constant. Much easier. Okay, this is much easier. So, what do we have to do? Change the directions, okay? Change the order, change the order of the integrations. How do we do it? First of all, we should actually, okay, we write again here. First of all, what you need to do is draw the area of integrations. Look at this. Look at the this is okay. I will write it again. Okay, e to the power of minus x dx dy. X is from to y to 4, and then y is from 0 to 2. So what do we need to do now? Draw this area. Okay, draw this area. X is between 2y until 4. and then y is from 0 to 2. Okay, now we draw it. Okay, this is y, this is x, and y itself is from, this is, let's say, 2. Okay, so y is from 0 to 2, and then x is somewhere from for these functions until 4. Let's say this is 4. Okay, so what do we have? Let's say this is kind of drawing. Okay, so this one is actually x is 2y. Can we draw it? If x is 2, then y is 4. This one. If x is 0, y is also 0. So what do we have? We have this line. Okay. This one is actually x is 2y. Okay. Where is then the area of the integrations? Okay. So from x is from this part to this part, this line to x is 4, and then y is from 0 to 2. So this one is actually the area of the integrations. So this one is r. Okay. Now look at this. We would like to change the directions from uh, this one is from x to y to become something that is integral dy dx. So okay, so first integrate with respect to y. Okay, and let's say this one. Okay, look at this one. Okay. I will use black. X y. Okay, y is from this point, so this one. Y is from 0 until this one, until this line. What does it? This line means? This line is actually, remember, we should write down as function of x. Okay, remember that function of x. This is not a function of x. Okay, function of x is y is x over 2. So this one is a function of x. So we have, what do we have? X over 2. Now, the x itself, the x is from 0 until 4, exactly the same. Okay, so this one is x. X is from 0 until 4. Okay, now we have the order now. Now let's calculate it. So now we we have e to the power of minus x squared dy. Now the dy is from 0 until x over 2. And then dx is from 0 until 4. Okay, let's see if we can solve this integral. Okay, now we solve this part first with respect to y. What do we have? Okay, first of all, I would write the integral of respect to x. E to the power of minus x squared, we integrate with respect to y. What does it mean? This one, we consider it as a constant. So we just write it down. Okay, and then times the y, because we integrate with respect to y. Okay, and then y itself is from 0 until y is x over 2. Then this one is the dx. Okay, so it is much easier than the previous one. Okay, 0 to 4, and then the rest. So we do it. Y we replace to x over 2, e to the power of minus x squared, then minus y is 0, and so this is 1 is 0. So this one is dx. So what do we have? X over 2 e to the power of minus x over 2 dx. How do we solve this? By using the previous method that we proposed. Okay, I will calculate it first here. X over 2 e to the power of x minus 2 dx. Okay, so I consider this is a substitution method. U is x minus x squared, du is minus 2x dx, okay, and then dx is minus 1 over 2x du, and then I rewrite it as I rewrite the integral as x over 2 e to the power of u, and then dx I replace with this one, okay, this is minus 1 over 2x times du. Okay, now I cancel something. Yes, the x. Okay, and then I have constants. I have a constants in this is 2 times 2. This is minus 1 4. Integral of e to the power of u du. Okay, this one is uh, minus 1 4. Okay, integral of e to the power of u itself. So resulting integration is itself. Okay, so we have, and then I rewrite again in x. This is 1 4. Sorry, this is 1 4 e to the power of minus x squared. So this one is the results of the integrations. Okay, now, sorry, not straight. So I will go on with the red coin again. So we have, what do we have? This is integral of, this is 1 4 e to the power of minus x squared with x is from 0 to 4. Okay, now now it becomes easier. Okay, I put out the 1 4 e to the power of 4 to the power of 2 is 16 minus e to the power of 0, which is 1. Okay, this 1 4 e to the power of, am I correct? Okay, I'll check again. Yeah, that's correct. It should be correct. Okay, e to the power 16 minus 1. So we have this result. Okay, so this one is the results of number 3. Okay. Okay, I hope you understand it. I hope I did not do something wrong in the calculations, but that's the idea, okay? The main point is you get the idea of how to solve it. It is not the detail of the calculation itself, but the the logical of thinking, the way of thinking to solve it. Okay, now we continue to the last questions. It's number 4. Okay, calculate triple integral now. Okay, triple integral. This is over b. Okay, I will define it later. 2x and then e to the power of y z. Now this is a dv volume. Okay, with b itself is defined as a set of x, y, z with conditions. Okay, the x itself is between 0 to 1, and then y is from 0 until 2. This is 1, okay, sorry. And then z itself is defined between 0 to 1. Okay, okay. Now we calculate it. There is no, seemingly the calculation is easy, boundary is easy. Let's say we can directly calculate. I will use right point. Okay, 2x e to the power of y z. I would like to calculate first with respect to x, okay, and then y, and then z. X boundary. from 0 to 1, y boundary is from 0 to 2, and then z boundary is from 0 to 1. Okay, now what do we have? Okay, I would uh, rewrite again the calculation. So we consider this integral. We integrate with respect to x. The rest of variables are considered to be constant. Okay, so we have e to the power of y, z. These are constants, and then x to the power of 2. Okay, we integrate from 2x to x to the power of 2, and then now x is from 0 until 1. Okay, then this one is still dy dz, and then put it here. Okay, rewrite again the integral 0 to 2, and then this one. I replace x with 1. What do we have? Just simple functions. Okay, and then this one is a dy dz. Now I will calculate integral with respect to y. What do we have? E to the power of y, and z is considered to be constant. Okay, z is considered to be constant, and then integrations of e to the power of y is actually the function itself, e to the power of y, and then y is from 0 until 2, and then uh, this is a dz. Okay, so I will just directly substitute that integral of 0 to 1 e to the power of 2 times the z minus e to the power of 0 is 1. Okay, and then times the z. So we have this dz. So what is the z? This one? We integrate directly e to the power of 2 times z to the power of 2 over 2 minus z over 2. Sorry, we don't have to do it. I think we just can simply put out the z, make e to the power of 2 minus 1 dz. Okay, this is much more elegant. Okay, and then with respect I integrate with respect to z. This is the z square over 2 e to the power of 2 minus 1, and then z is from 0 until 1. Okay, and then we have 1 over 2 e to the power of 2 minus 1. So finish. Okay, this one is the result. Okay, so I do hope that my calculation is correct. If not, please revise it. Okay, so I do hope that I do not make any mistakes. But if I did, so please forgive me. Okay, I would like to share the idea to you so that you can do yourself let's say the exercises for the examinations. Okay, so basically what you need to remember is actually the idea itself. It's not really the numbers, but the ideas of these techniques of integrations, especially for double integral and triple integral. Okay, so I do hope you enjoy the video. uh, okay, see you again in the next exercises. Okay, thank you very much. Good afternoon.